In this chapter, we're talking about similar figures, and we've looked at the fact that similar figures have sides that are proportional. So we need to talk about proportions. So we're going to begin talking about ratios and extended ratios, and then we're going to talk about proportions and cross-multiplying, which we've done cross-multiplying before, but we're going to look at a variety of different properties of the proportions, and that's what we're going to cover today. So let's start off with ratios. All right, so we're going to use the letters A and B here just as placeholders. They can be two numbers, they can be two quantities, they can be two things, but when you compare them to each other, that's called a ratio. And so you can write it like this, or this, and that's how we'll usually look at them. They look like a fraction, and yeah, when you have a fraction, you're comparing the numerator to the denominator. Or if you write it side by side with the colon, the way you say this is you say it as A to B. So you're comparing the first value to the second value. We're always going to simplify the ratios, always, always. And ratios, the final answer, the ratios will have no units because those units are going to cancel out. And we'll see that happen in these examples. Now, if you were to set two ratios equal to each other, then that makes a proportion. And we'll be looking at proportions down at examples 3 and so on. But right now, we're going to start off with just one ratio, and that's what we see here in example number 1. Let's simplify the ratio. You can see that some of these are set up with the colon symbol, some of them are set up looking like fractions. Some of them are just using the word 2 instead of the colon symbol, but we're comparing one number to another. And as long as the units are the same, then it's pretty easy to compare those numbers. But if the units are not the same, then it's not so easy to compare the numbers. And remember, the units have to cancel out. And they'll cancel out if they're the same, but if they're not the same, then we have to convert the units. All right, so as a technique, I'm going to take these two numbers that we're comparing and rewrite it like a fraction. So 76 centimeters is on the top because that's listed first, and what's listed second goes on the bottom like this. We're usually reducing fractions, and so putting it in this fraction format can help. Now you want to think about what's happening with the centimeters over centimeters. We've talked briefly about, in past lessons, about reducing, and so I'm going to borrow some of this margin space over here. If you're reducing a fraction like 5 over 5, anything divided by itself is 1. Here's another little example. If you have x divided by x, the answer is not x, but 1, right? Anything divided by itself is 1. So we're going to see a very similar pattern here with units. If you have inches divided by inches, well, they just cancel out. Or if you have centimeters divided by centimeters, they cancel out. All right, anything divided by itself is 1. So here in example number 1, part A, we have 76 centimeters over 8 centimeters. And so centimeters divided by centimeters cancels out. And that's what we're seeing. And then we're just reducing the number, 76 over 8. So that's going to be top and bottom is divisible by 4. And you can use your calculator to determine what that is. So 76 divided by 4 gives you a result of 19. 8 divided by 4 gives you a result of 2. So notice we're not going to decimals. We're just simplifying the values as far as we can. We cannot divide any farther. We cannot divide out a factor of 2. 19 is not divisible by 2, so we can't go any farther. So we're going to return this back into the same format that the problem gave us. We're going to write it side by side with the colon in the middle. We will say 19 to the number 2, right? And so that's our reduced ratio. Now, in a case like this, where you have different units, they don't cancel out, do they? So we need to set up a multiplier. So we're going to use something called unit analysis. We're going to start off with the units. Now, remember, we want the units to cancel out. They're not ready to cancel out, but we need them to. So to make that happen, we're going to set our multiplier up in such a way that we will take take the feet that you see on the top and put it in the bottom. And take the inches that you see in the bottom of the problem and put it in the top. That way we can have inches canceling out with inches, and feet will cancel out with feet. But we have to have numbers in here. How many inches are there in a foot? We know there are 12 inches in 1 foot. So we're setting up a multiplier, and this fraction here, its value really is 1, because 12 inches is equal to 1 foot, but we're setting it up in such a way that we have 2 different units. So now when we multiply these together, all right, you multiply top times top and bottom times bottom on your fractions. So 4 times 12 is 48. And you have feet times inches. Well, that means you have feet, and that means you have inches. And on the bottom, 24 times 1, and you have inches times feet. So that means you have inches, and that means you have feet. So look at what happens to the units. Feet cancels out with feet, and inches cancels out with inches. So that's how we make all of the units disappear. 48 is divisible by 24 and gives us 2 to 1. So that is our reduced ratio, our simplified ratio. All right, here in part C, we do have the same units of meters and meters, so that will cancel out very quickly. All right, so the meters drop out. The numbers 4 and 18 are both evens. We can factor out a 2, and that gives you 2 to 9, so the answer is 2 to 9. All right, here's another one where we have different units. So 33 yards is on the top and 9 feet is on the bottom. So let's set up our multiplier. Again, the technique here is we're going to identify what units we have and put that matching unit on the bottom, or on the opposite side of that division bar. So if yards is on top, we'll put yards on the bottom. And if feet is on the bottom in the problem, we want to put feet on the top. And now we ask ourselves, how many feet are in 1 yard? And so 3 feet have the same length as 1 yard. And now we're going to multiply these together. All right, so 33 times 3 is 99. And yards times feet is just yards times feet. 9 times 1 on the bottom is 9, and feet times yards. Right, and you can see that yards cancels out with yards, feet cancels out with feet, and 99 divided by 9. Now remember, you have to have an answer with 2 numbers, so you can't just say the answer is 11. You have to say it's 11 over 1. And then put it back in the format matching the problem. So we'll say 11 colon 1. So there's your simplified ratio. So that's the first skill. In a moment, we'll be taking a look at setting ratios equal to each other. 2 ratios equal to each other will make a proportion, but we're not quite ready for that. We're still talking about a ratio, and a ratio, we've said, was a comparison of 2 numbers. But it turns out there are some problems where you can compare more than 2 numbers. For example, example number 2, we have a situation where we are going to compare not just 2 numbers, but 3 numbers. We're comparing 2 to 3 to 4. So we call that an extended ratio because it's more than 2. The measures of the angles in this triangle BCD, are in the extended ratio of 2 to 3 to 4. So because a triangle has 3 angles, we need 3 numbers to compare them to. Let's find the measures of the angles. All right, so these are your 3 steps. First of all, you have to draw a diagram. And in our case, it's a triangle. And part of the diagram is putting the information inside. And since these ratios are representing the angles, we're going to put them not on the sides, but on the angles. So we'll have a 2, a 3, and a 4. So there's the 2, there's the 3, there's the 4. Now these are not the answers. It's not 2 degrees, 3 degrees, and 4 degrees, because you know the angles have to add up to 180 degrees, and these certainly don't. So what that is telling us is something is missing. All right, and so we're going to bring in a variable. Let's call it 2x degrees, 3x degrees, and 4x degrees, because x is representing that scale factor that we need to find to return it back to the original size. Remember, these ratios are reduced. It's sort of like if we were to borrow an example here. If we said, hey, here's a ratio of 19 to 2, can you scale back up to something bigger and like kind of returning it back up to the original and bigger numbers? We need to do the same thing with the triangles, angles. We need to return these back up to their original and bigger numbers. So that x is the scale factor. We want to figure out how many times bigger do we have to make it. Do we need to make it 2 times bigger? Do we need to make these ratios 5 times bigger or 10 times bigger? That's what we're trying to figure out. So once we've got our diagram all set, that will then lead us to our equation. This is our second step. And because we're talking about the angles in a triangle, and we've understood that they add up to 180 degrees, we could say 2x plus 3x plus 4x equals 180. We've learned that before. Now we combine like terms. We get 9x. Divide away the 9 from both sides to isolate the variable. And what this 20 represents is the scale factor. We need to make the ratio of 2 to 3 to 4 20 times bigger so that we can find the measures of the angle. So these are the original angles now, and this is our third and final step. We're going to solve for the measure of the angles. All right, so the measure of angle B, that's 2 times x, so 2 times 20 is a 40-degree angle. The measure of angle C is 3 times x, so 3 times 20 will give us a 60-degree angle. And lastly, the measure of angle D is 4 times x, so 4 times 20 is 80. That's an 80-degree angle. So we can double check by adding these up. These three angles better add up to 180 degrees because they're belonging in this triangle. It's like if we said, hey, here's 3 angles, 40 to 60 to 80 degrees. Can you take those numbers and reduce until you can't reduce anymore? You would end up with this ratio of 2 to 3 to 4. So what we're saying is, for every 2 degrees in the first angle, there's a corresponding 3 degrees in that middle angle, and there's a corresponding 4 degrees in that third angle. So 40 degrees has, for every 2 degrees, there's a corresponding 3 degrees in that middle angle of 60 degrees, and then there's a corresponding 4 degrees in that third angle. That's what that reduced ratio is telling us. It sort of takes the pattern of the 3 and breaks it down to its most simplest structure. So this is one example where we have an extended ratio. Let's look at another. Here in part B, we're talking about a rectangle. So the perimeter of the rectangular table is 21 feet, and the ratio of the length to width is 5 to 2. Well, that's only 2 numbers, so it's not exactly an extended ratio. It's a ratio. But once again, we're going to go through this same sequence of steps where we start off by drawing a diagram. And in this case, it's a rectangle. Now, they're telling us that the perimeter is 21 feet. So if you were to measure all the way around and add up the length of all 4 sides, you would total up to 21. We don't know what those numbers are yet. That's what we're trying to find. We're trying to find the length and the width. So we're kind of working backwards here. We're starting off with the grand total of the perimeter and working backwards to figure out what the length and width must be so that they can add up to 21. Right? Step number 2, we have to write our equation. I guess we're not quite ready. Let me go back to the diagram and add a little detail here. Because we have this length to width ordered in this way, and the number 5 comes first and the number 2 comes second, let's pair up the length to the number 5 and the width to the number 2. All right, so let's label our sides. Here's my length and here's my width. Now we can't write the equation yet because if you use length and width, that would look like 2 different variables, and that's not helpful. We just want one variable. So we're saying the ratio of the length to width is 5 to 2. So the length gets the 5 and the width gets the 2. But remember, these numbers have been simplified. We need to unsimplify them. We need to scale them back up again. So that means, again, we need a variable that represents a multiplier. We just don't know how many times bigger to make it. Do we need to make it 2 times bigger? Do we need to make it 3 times bigger so that all the sides add up to 21? Let's find out. So now we're ready for the equation. Remember, we have 4 sides here. We're talking about a perimeter. We're going to add up all 4 sides to 21 feet. So it has nothing to do with 180 degrees. Remember that 180 degrees that we saw in the previous example was only 180 because we had a triangle, and we're talking about the angles in a triangle. Here, we're not talking about the angles in the rectangle. We're talking about the side lengths because perimeter is the distance around the side. So you have to pick your equation that matches the situation they give you. So here's a length of 5x. Then here's a width of 2x. Then here's the top side, which is again a length of 5x. And then here's the left side, which is a width of 2x, right? So you add up all 4 sides and you set it equal to 21 feet because that's what the problem gave us. So now let's combine like terms. 5 and 5 is 10, and 2 and 2, that's another 4. That's 14x equals 21. So we're going to divide both sides by 14, and x is 1.5. So that means we're going to scale this up by 1.5 times. The question asks for the length and width. So we are going to solve for the length and the width in this final step. So the length we had represented as 5 times the scale factor. So 5 times the scale factor of 1.5 gives us 7.5 feet. And the width, which is represented as 2 times the scale factor, is 2 times that 1.5 scale factor, and that gives us 3 feet. So those are the final answers. So if we had 7.5 and 3 feet, we added those up all 4 sides, that would total up to the 21 feet there. So that's topic number 1, starting off with ratios, and in this case the extended ratio with the triangle, but using these story problems to be able to set up an equation to solve for that missing scale factor. So now what we're going to do is we're going to create an equation that will take 2 ratios and set those ratios equal to each other to make a proportion. So we're going to talk about proportions now for the rest of these examples. In the box at the bottom, they give this a very fancy name, but this is essentially just cross multiplication. And so what it is you have this if and then, right? And what we're doing is we're setting you up with cross multiplication. So here's a ratio on the left side of the equal sign. Here's a ratio on the right side, right? You have a fraction on the left, you have a fraction on the right, so you can cross multiply. Now they give these fancy names. They call this the means, and they call the A and the D the extremes. So think of the means are in the middle. So if you alphabetize this A, B, C, D, B and C are in the middle. So the means are in the middle. So we're going to multiply the means. We're going to multiply the B times C. You get a B times C. And then we're going to multiply the extremes, the first and the last letter, the A times D. And that's what you get. You get an equation that doesn't have a fraction anymore. So we've done this before. Let's take a look at some cross multiplication. All right, so here we're going to multiply 4 times x. Set that equal to 3 times 16. And look at that, you don't have any fractions anymore. So let's see, 3 times 16 gives us 48. And divide both sides by 4 to isolate the variable, and we get a result of 12. All right, part B, let's do this again. Here we're going to multiply 2 times y, and that equals 8 times 5. The fractions are gone. 8 times 5 is 40. Divide both sides by 2 to isolate the variable. We get an answer of 20. So it's a little bit trickier with an example like this next one, where we have a binomial. Look at that x minus 3, right? So just keep an eye on that. So once again, we're going to cross multiply. So here we have 3 times 2x. I'll multiply that in a moment to 6x, but I'm just writing it down, 3 times 2x. And then when you multiply in this direction, you want to 9 times that x minus 3. It's super important you put parentheses around that binomial because we're going to distribute the 9. That means we're going to multiply the 9 to everything in that group. So on the left side, 3 times 2x is 6x. On the right-hand side, 9 times x is 9x. 9 times a negative 3 is a negative 27. So now we have 2 terms of x. I'm going to bring them all to the left side. I'm going to subtract 9x from both sides. So we have a negative 3x equals a negative 27. And then we're going to get x by itself. Since x is currently being multiplied by that negative 3, we need to divide both sides by negative 3. So that'll get us our x by itself, and that gives us an answer of positive 9. So these are the basics, okay? And we're about to show you, other ways to set up proportions. There's several different patterns that we can look at. So I'm going to call this the first pattern. I'll just call it number 1 because it's sort of like the standard pattern, A, B, C, D in that order. All right, we're going to be using these letters, A, B, C, D, and showing you different ways we can set up the exact same proportion. And we'll do that here at the top of the next page. All right. So in that box that you're seeing up there, what you're looking at is just kind of the description of what we're about to do, right? So this is the first pattern that we just saw, A, B, C, D. In that exact same order, we can cross-multiply that. But what we're going to do is we're going to manipulate it slightly and show you other ways of setting this up. So if A over B equals C over D, then they're reciprocals. Remember, reciprocal means you're going to flip the fraction upside down. So let's take each of these fractions and flip them upside down. So if you flip the left side upside down, you must also flip the right side upside down. So ABCD is now BADC. But if you cross multiply, you get the exact same results. You get B times C and A times D, which is exactly what you would have gotten originally. So let's call that pattern number 2. Here's a third pattern, right? So number 3. Once again, we're starting off with the basic A over B equals C over D, A, B, C, D. This time we're going to interchange the means. Remember, the means are in the middle, so we're going to take the B and the C and exchange their places. So if you set up your proportion, the A is still on that top left, the D is still on the bottom right. We're going to take the B and the C and swap their places. So let's put the C under the A and the B over the D. Now, if you cross multiply, will you get the same result? Sure you will. You're still going to multiply B times C, just like you did here. You're still going to multiply A times D like you did here as well. So this is another correct way to set up a proportion. Here's our final pattern. This is the more complicated pattern here, but again, we're starting off with that original setup of A over B equals C over D. So in this proportion, if you add the value of each ratio's bottom to its top, we're going to add the denominator to its numerator. So we're going to take the thing on the bottom and we're going to add it to the top. All right, now we're not adding it to both top and bottom. We're taking the thing on the bottom and adding it to the top. So let's see what that looks like. What that means is the bottom is still the same. You still have the B and you still have the D on the bottom. That doesn't change. What changes is the numerator. We're going to take what you see on the bottom, which is the B, and add it to its ratio's top, the numerator. So we have an A on the top. We're going to add on to that what we see underneath it. So it's A plus B over B. We have to do the same thing over here on the right-hand side. We're starting off with the C. We're going to add on to the C what you have on its own bottom. D is in the denominator, so we're going to add that to the numerator. So it looks like A plus B over B equals C plus D over D. Now that does not intuitively look like the same. If you cross multiply, will you get the same thing? Let's find out. We're going to use example 4 to go through each of these 4 patterns. Now in your book work, they are going to give you a picture with some numbers on it, but they're also going to tell you what ratio to set up. Do you see this information here? They're literally saying, put this number on the top, put this number on the bottom, put this on the top, put this on the bottom. So it's like a map. You got to read that, find the number or find the information in the picture and put it in the right spot. So this is the original pattern. Let's call this pattern number 1. Okay, so here is our very first pattern because they're telling it to us. So let's find length of AC. There it is. AC is 12, so 12 goes on the top. Under that is length of DF. DF is 18, so 18 goes on the bottom. Top right is BC. BC is 9, so put 9 on the top. And EF is just the variable x, so that goes here on the bottom. Now, we'll solve for x in a moment, not just yet. We're just setting up these proportions using these 4 different methods. That's the standard method number 1. So this is going to be method number 2. And we said in method number 2, you could take that proportion and flip it upside down, and it would still be the same thing. So let's flip this upside down. We'll have 18 over 12 equals x over 9. We could cross multiply, and we'll get the same result. Here's the third pattern. The third pattern says you can exchange those 2 numbers in the middle, and it will still be true. So we're going to exchange the 9 with the 18. So the 12 stays where it is, the x stays where it is. We're going to exchange the 9 and the 18. So 9 is underneath the 12 and 18 is above the x. If you were to cross multiply 9 times 18, it's exactly the same as 9 times 18, right? So that doesn't change anything. You get the same result. Here's the fourth pattern. This is the weird one. All right, so again, you're going to take the bottom and keep it the same. So that's still an 18 and that's still an x. This pattern says you're going to take that bottom value and add it onto the top. So you're going to have a 12 plus the 18. And then on the right side, you have a 9 plus the x. Now, because these are like terms, we can combine them. So we're going to simplify this a little bit. 12 and 18 gives us 30 over 18. And that'll equal the 9 plus x over x. So that's pattern number 4. And it doesn't look the same. It doesn't look like if you cross multiply, you'll get the same thing. But we're going to do that right now. Let's solve for x. So let's use pattern number 1 to verify we know how to get x. And then let's compare that with pattern number 4 to verify that this will also work. So here's pattern number 1. We have 12 over 18 equals 9 over x. Let's cross multiply. So 9 times 18 is a pretty big number. That gives us 162. 12 times x. Let's divide both sides by 12. And we get 13.5. All right, let's take pattern number 4 and show you that it works out as well. So I'm just going to rewrite this again. Here is 30 over 18 equals 9 plus x over x. All right. When I cross multiply here, I'm going to wrap the 9 plus x in parentheses. So we have 18 times the binomial, 9 plus x. That is equal to 30 times x. So now I'm going to take that 18 and distribute it to the binomial. So 18 times 9 is 162. 18 times x is 18x. That equals 30x. Let's move all the x's to the right. I'm subtracting 18x from both sides. And I get 162 is on the left, and on the right-hand side, 30x minus 18x is 12x. Does that start to look familiar with what we had over here in the previous pattern? Divide away the 12, and we get an answer of 13.5. Yeah, so you get the same result. So that's just to verify that this fourth pattern, though it looks so different, really is an equivalent proportion. So let's finish up with example 5. These are a couple more patterns with proportions and pulling information off of the diagram. All right, so here at example number 5, you can see that we do have 2 shapes. It's just that you have a smaller shape layered on top of a much bigger shape, right? So they're small triangle and big triangle. And this tells you how to set up the proportion. It says take the length you see from J to L, put that on the top. Take the length from L to H and put that on the bottom. All right, well, JL is unknown. I actually don't have any information here. And I can't use x because x is already described as this whole thing, okay? So that's a little bit of a problem. So let's pick a new variable. Let's just call that y. So let's put y on the top here. The length of LH is 2. The length of JK is 15. And the length of KG is 5. There's our proportion. Let's cross multiply. 2 times 15 is 30. 5 times y. And then divide away the 5 and we get a result of 6. Now, that just means this side that we threw the y on is a length of 6, but we have to go back and double check that we've actually answered the question. How long is it from J to H? Well, J to H is the whole right-hand side, which they are calling x. So to find JH, that's the same as finding the variable x, and that means we have to add up these two lengths to get a result of 8. And then how long is it from J to L? Yeah, that's what we just figured out here. So this y that we called 6, that's the JL. Oops, JL. Right, so those are the two results that they wanted us to find. Let's do another one. You can try this one, see if you can set this up. They're saying KL over GH equals JK over JG. Right? So pause the video here, see if you can set that up and cross multiply. Right, KL is 12. GH is unknown, right? So that's your variable. So you can pick a letter or you could just call it GH. That's going to be the variable we need to solve for. And then JK is the 15 and JG is, well, JG is this entire length. So we have to add up those pieces. We have to add up the 15 and the 5 to get to the 20. So that side is 20. That's your setup. Let's cross multiply. So we have 15 times GH equals 12 times 20, which is 240. Divide away the 15 to get your variable by itself, and we get 16. Right, so in a case like this, you have an option. You can either just pick a letter to represent that missing segment, or just use the segment name itself as your variable, and that's what I did here.